We are going to discuss about S block elements. S block elements, you can define them as those elements in which the last electron or the differentiating electron enters S subshell of the valence shell. I'll write the definition here. Last electron enters S subshell of valence shell. So, any element in which the last electron enters S subshell of its valence shell can be regarded as S block element. In S block of long form periodic table, there are two groups. You can have only two groups because S subshell can accommodate maximum of 2 electrons. So, the two groups are labeled as 1A and 2A groups. So, S block consists of two groups. The two groups are 1A group and 2A group. The 1A group elements are called alkali metals and the 2A group elements are called as alkaline earth metals. I'll repeat this. S block consists of two groups, 1A and 2A. So, the reason why it has two groups is due to this fact that S subshell can accommodate a maximum of 2 electrons in it. So, there are two groups, alkali metals, which is 1A group. These elements have only 1 electron in their S subshell, whereas alkaline earth metals, that is group 2A, these elements have 2 electrons in their S subshell of valence shell. So, S block basically deals with the chemistry of alkali metals and alkaline earth metals. Now, let us learn about alkali metals now. Alkali metals. Alkali metals are the elements which belong to 1A group of long form periodic table. They have 1 electron in their valence shell. Look at the list of elements in this group. Lithium, symbol is Li. Sodium, its symbol is Na. Potassium, K. Rubidium, Rb. Cesium, Cs, and francium, Fr. These are the elements you have in alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. What is common for all these elements is all of them are metals and all of them have 1 electron in their valence shell. We will be looking at the electronic configuration of after a short while. Now, let us put the atomic number. Atomic number of lithium is 3, sodium 11, potassium 19, rubidium 37, cesium is 55, and francium is 87. Now, they all have a noble gas core. For example, lithium has helium core, and out of which you have got in the outermost shell, it has got 1 electron. Neon core is present in sodium and there is 1 valence electron which is present in S subshell. There is argon core in potassium, 4s1. Krypton in rubidium, 5s1. Xenon, 6s1, and radon, 7s1. This is how you can represent their outermost electronic configuration, which is present after a noble gas core. You can see the common feature, they all have 1 electron in their valence shell. So, when they enter into chemical reaction, they tend to lose 1 electron, because when they lose 1 electron, they attain configuration similar to the nearest inert gas, and their oxidation state in all their compounds is +1. That is the reason. They participate in chemical reaction by losing electrons. That is a characteristic of metals. because they lose only one electron, their oxidation state in all their compounds is +1, and their compounds are mostly ionic. You can write general electronic configuration as NS1, indicating that they all have one electron in their valence shell present in the S subshell. That's the general electronic configuration of these elements. For your information, let me tell you, francium is a radioactive element with a half-life. T half of francium is just 21 days. It's a very short-lived element, highly radioactive, and we will not be talking about chemical properties of francium. See, for any radioactive element, it is not possible to study its chemical properties fully. So, we will be mostly dealing with elements from lithium to cesium. Now, let us talk about general trends in their physical and chemical properties now. This is the list of elements. Please go through the list. Lithium, Li, its atomic number is 3. This is electronic configuration represented like this, where you have helium core and one lone electron in the S subshell of 2s subshell. Sodium, Na, atomic number is 11. Potassium is K with atomic number 19. Rubidium is Rb, atomic number is 37. You have then cesium 55. So, this is the list of alkali metals. We are now going to talk about their general trends in their physical and chemical properties one by one. Let us proceed further for general trends in physical and chemical properties of these elements. First, we will talk about their physical properties, then we will go for their chemical properties.